You may have noticed that in all of the parameters we don't mention voltage. The reason for that is the parameters are set there for safety reasons, and it is not the voltage that kills you, it's the current that kills you. So all of the parameters refer to the current or how the current through a fault condition can be limited. And if it can't be limited, how it can be safely drained off through the earth wire. Okay, how does it kill you? It kills you by paralysing or damaging your muscles. And again, it is not the voltage that does this. You can quite safely, without killing yourself, it'll hurt like hell, but you can hold on to an electric fence which has many thousands of volts. A mega-ohmmeter puts out 500 volts. Our mega, which does the 500 volt test, puts out 500 volts. But it isn't lethal because we have limited the current to around about 1 milliamp, 1.5 milliamps. And as you can see from the scale below, 1 milliamp is fairly harmless. Don't think it won't hurt. If you grab hold of the leads of a mega, it hurts. But note what the effect of the different currents have on your body. As I said, at 1 milliamp you can hardly feel it. Well, you can, but it won't do any real harm. 5 milliamps it is really starting to burn. It's interesting to note also that 1 milliamp is the maximum for class 2, 5 milliamps is the maximum for class 1. Once you get to 8 to 12 milliamps, you're starting to get muscle spasms. And from 12 to 20 milliamps you're unable to let go. I have been to lectures and I have heard people say that if you think something may be live, just touch it with the back of your hand so that your muscles won't then contract and you won't be able to let go. I say if you think it might be live, don't bloody touch it. Isolate it first. Or if you can't isolate it and you think something might be dangerous, call your local Sparky. Don't stick your finger in it to see if it's live, because believe me, it will hurt. From 20 to 50 milliamps, this is where you're starting to really get into the bitey stuff. This is where you're going to die. That is why RCDs trip at 30 milliamps. They actually trip at about 22 to 24 milliamps, but we test them at 30 milliamps. And they must trip within 300 milliseconds. That's about 0.3 of a second, a bit less. That is the maximum calculated values that the human body can stand without dying. After 50 milliamps, you might as well forget it. You will either be dead or seriously burnt. Okay, element 2.4. Visual checks on the cord assemblies and cord-connected apparatus are carried out in accordance with established procedures to detect any abnormal or obvious damage or fault. As we've said before, this is the single most important test. This is a test you must religiously do and never ever avoid it. 80 to 90% of your faults will be found in this test. If you do not do this test, and there is mechanical damage done to the appliance, when you test it you are putting yourself in danger, so you must do this test. I cannot stress that enough. And here are just a couple of things you should look for. This is a plug that I actually took from a factory. It's a 15 amp plug and it wouldn't fit in their 10 amp socket, so they cut the earth off. Here's another one I took from a workshop. You can see that it is a rewirable portable RCD. Came off a piece of portable equipment, I can't remember what it was. But if you look in closely, you will see that the earth is totally missing. They've just wired it onto a 2-core flex. But if you look closer here, you will see that half the wires aren't even under the terminal screw. And that's a real problem because you've limited your current carrying ability of the cables. That's going to get very hot there if it's under any particular load. And then the next one we have here was in a factory. Again, it was in a hydraulic workshop. This is a hydraulic pump. And as you can see, it's brand new. There's not a mark on it. You would expect to see oil and stuff on it if it's from a hydraulic workshop, but it's brand new. And if you look here on the terminal block, you'll see the earth wire comes in here. That's a plastic stud. Over here is a plastic stud. and between the two there is an air gap. Nobody had ever connected this from new. The moral of this is, well, there's two morals here. Don't expect stuff coming out of a factory to be compliant. As you'll see later, I show you another couple of examples where stuff comes out of the factory brand new and totally not completed, as this is. They've just forgotten to put the earth in, and this is dangerous. This is on, I'm not sure how big it is, probably a 5 horsepower motor bolted to a metal frame. Very dangerous. The second moral here is trust your instruments. Trust your test equipment. If your test equipment says that it fails, there is a 99% chance that the test equipment is right. Element 2.5. The statement from the learning outcome on this one is, approval is obtained in accordance with established procedures from appropriate personnel before any contingencies are implemented. Don't go into an area where you have no authority and no knowledge and start implementing your plans. Generally, if you're working for yourself in your own work area or for your company, this shouldn't be a problem. But if you're going to be doing this professionally and you'll be going into other people's premises and work sites that you are not familiar with, you must never ever just walk onto a site and start work. You must check for safety issues, you must check that you're not going to cause a problem, disrupt the workplace, shut down plant that is running without first consulting the person in charge. Element 2.6. Established PAT routines are followed to test cord-connected assemblies and cord-connected apparatus. We won't bother too much with this here. Notice that everything so far has been established routines, and that is what Certificate 2 is. You don't reinvent the wheel. You follow established routines. Even though each situation will be different, the routine that you will go through and the procedures that you will use will be the same. When you get into the practical section, you will see that this is probably, well, it is the easiest section of the lot. The course is directed to our own equipment, which is probably the easiest equipment on the market to use. If you are using somebody else's equipment, I'll be happy to talk you through it. I have worked with most of them. If you are not using our equipment, give me a call and I'll be happy to talk you through it on Skype or some other audio-visual means. But whatever equipment you use, the procedures and the routines are already established and you shouldn't have a problem with them. Your tester, regardless if it's one of ours or somebody else's, is a piece of electronic equipment, therefore it has to be looked after. Most of them are fairly robust and will handle a reasonable amount of biffo, but it is better that you look after it as we recommend. Obvious things like don't drop it, don't drop anything on it, store it and transport it safely. That is one of the reasons we produce the kits. All of our tester range come with a very sturdy aluminium case which is foam rubber lined, and everything you will need to do your testing and tagging is in the kit. Liquids are a big no-no, liquids of any sort. On any electrical or electronic equipment, they do not mix. Don't damage the power cord, but this is a big one. We always recommend, and you must do this, that you use a portable RCD when you're using any appliance testers. A couple of reasons for using a portable RCD. Firstly, the obvious, but secondly, if you're working in somebody else's premises, you'd have no idea how long since they've been tested, if they've ever been tested at all, or in fact if they actually have one. So you may well be working on a circuit which is not effectively protected, and you will be testing equipment that may have a fault and you may be exposing yourself to danger. We highly recommend that you use a portable RCD with any portable appliance tester that you're using. And it doesn't say in the standard that you have to have your equipment calibrated. It may in some local health and safety regulations, but it is best practice to have them calibrated every 12 months. The standard only says they must be regularly checked, but we recommend that you have them calibrated every 12 months. Because if your tester is not accurate, obviously your results will not be accurate. Element 2.7. We're nearly there. There's only one more section to go in element 2. The outcome from this one is going to be unsafe cord assemblies and cord connected apparatus are identified from test results. If you're using an appliance tester, which you should be, it will give you a pass-fail result. In a later section we'll do a fair bit on documentation, what you do after you identify whether an appliance is safe or unsafe, and what sort of tag you put on it and what you do with the appliance. Basically what you do, you take the appliance out of service into a quarantine area. You either repair it yourself or you have somebody qualified to repair it for you. Element 2.8. This is the last of the element 2. Testing is undertaken effectively with minimum waste of energy and damage to apparatus. Okay, if you're using a recognised portable appliance tester, it would be very, very rare, extremely rare, to do any damage to any electrical equipment. The only way you could probably damage electrical equipment would be the incorrect use of a handheld megometer. That is a subject for another day and is not covered under this course. There are a couple of reasons I haven't included the mega in this course. One of them is, to use a mega correctly, you have to be able to interpret the scales, and that is outside of the scope of a distance learning program. The second is, if a mega is not used correctly and 500 volts are put across electronic equipment, you will do some damage.